a car of mass 2400 kg. So this is my M, 2400 kgs, moving with a velocity of 20 meter per second. So this is the U, initial velocity 20 meter per second, is stopped. Stopped means V final velocity equal to 0 in 10 seconds. So time equal to 10 on applying brakes. Calculate the retardation and the retarding force. So here we've seen the mass, which is M equal to 2400. So we've seen the initial velocity is 20 meter per second. The final velocity, it stops, so it is 0 meter per second, and the time taken for it to stop is 10 seconds. We need to find the retardation. Now, formula for retardation: A equal to V minus U over T. So A, we know the V is 0, the U was 20, and the T was 10. So we have A equal to minus 20 over 10. So A equal to minus 2 meter per second square. Why did the retardation come negative? Because here the body is slowing down. It is stopping. The velocity is decreasing. There is a decrease in velocity, and that is called retardation. Now we need to find the force. By Newton's second law, we know the formula for force equal to mass into acceleration. Now force equal to the mass in this case is 2400, and we saw that the acceleration was minus 2 meter per second square. So the force will be 4800 newtons. Why did we get negative? Because it is a retarding force. It is in the direction opposite to the motion. For how long should a force of 100 newtons, so F equal to 100 newtons, act on a body kg, so M equal to 20 kg, so that it acquires a velocity of 100 meter per second. So final velocity is 100 meter per second. So the body here is starting from rest, which means U must be 0 meter per second, and we need to find for how long, means we need to find the time. So let's put in the values. We saw the force was 100 newtons, the mass was 20 kg, the initial velocity was 0 meter per second, and it acquires a velocity of 100 meter per second. So final velocity 100 meter per second, and here we needed to know the time. The time T was our question. So we start with Newton's second law, which says F equal to M into A. We know the F is 100 newtons, the mass is 20, the acceleration we do not know. So the acceleration equal to 100 over 20, that is 5 meter per second square is the acceleration. Here the acceleration is positive because the body is increasing its speed from 0 to 100 meter per second. Now we need to find the time. The formula for acceleration is V minus U over T. So let's put the values. We know our acceleration is 5, the final velocity is 100, the initial velocity is 0, and the time is T. So 5 equal to 100 over T. So time T is 100 over 5, and the time T is 20 seconds. Find the acceleration. So the acceleration is question. We need to find produced by a force. So the force here is 5 newtons acting on a mass of 10 kgs. So again, by Newton's second law, we have F equal to M into A. Now the F is 5, the mass is 10, and the acceleration we need to find. So acceleration is 5 over 10, that is 1 by 2 equal to the acceleration, and the unit of acceleration is meter per second. square. A 1000 kg vehicle, so mass is 1000, moving with a speed of 20 meter per second. So the initial speed is 20 meter per second, is brought to rest, means final velocity is 0 meter per second in a distance of 50 meters. So here distance is 50 meters. We need to find the acceleration. Now we have the three equations of motion. These are the three equations of motion. Now which one do I start with? Look at the first. In the first one, we know V, we know the U, but we do not know A and we do not know T. We have two unknowns, so we cannot use this equation. Let's go to the second one. We know S, we know U, we do not know T, again we do not know A. There are two unknowns, so we reject this equation also. So we are left with the third equation. So we have V square equal to U square plus 2AS. This is how you go to choose your equations. Now let's put our values. So we know our V is 0 meter per second, the U is 20 square, 2A we do not know, but the S is 50. However, here I should have written all these information first. Mass was what, 1000 kgs. The initial velocity U was 20 meter per second. Final velocity was 0 because the object was brought to rest, and the distance was 50 meters. So on solving this, we will get now 0 equal to 400 plus 100A. The 400 goes on the other side, so I get minus 400 equal to 100A. And the acceleration equal to minus 400 over 100. And the acceleration turns to be minus 4 meter per second square. So we found the first part. Here we found the acceleration for this as minus 4 meter per second square. Why did the acceleration come negative? Because remember, the body is coming to rest, is brought to rest, so the speed is decreasing. If the velocity is decreasing, it is said to be acceleration. Now the second part, they said find the force. So by Newton's second law, we have F equal to M into A. So F equal to M we know is 1000, and the A is minus 4, which we have found out here, the acceleration minus 4. So the force is minus 4000 newtons. It's a retarding force. Because it has come negative, we can say it's a retarding force. What is the force? So F is a question mark, which produces an acceleration of 1 meter per second square. We put square here. So acceleration is 1 meter per second square in a mass of 1 kg. So mass 1 kg. So force we need to find. We have acceleration. So acceleration was 1 meter per second square. The mass was 1 kg. We go to Newton's second law. Gives us the magnitude of force, F equal to M into A. So we have F equal to, the M is 1 and the A is 1. So the F is 1 Newton. A body of mass 2 kgs. So M equal to 2 kgs at rest. It's at rest means the initial velocity is 0 meter per second. What should be the magnitude of the force? So we need to find force here, which will make the body move with a speed of 30 meter per second. So we are pushing the body, and now the speed becomes 30. So final velocity is 30 meter per second at the end of 1 second. So time is 1 second. So here we've seen that the mass is 2 kg. The initial velocity U is 0. The body is starting from rest. and the final velocity is 30 meter per second. We have to push it to get a speed of 30 meter per second, and all this has to be done in 1 second. So we need to find the force. By Newton's second law, we have F equal to m into a. Now we need the a, and we do not know the a, so let's go ahead and find the a, the acceleration. Acceleration is v minus u over t. So a, now v we know is 30, the body is starting from rest, so initial velocity is 0 and the time is t. So a equal to 30 over 1, a equal to 30 meter per second square. Now to go back to the sum to find the force, we have F equal to, we know the mass is 2, which is given to us, and we found out the acceleration to be 30. So we multiply this by 30. So we have here F equal to 60 newtons. So the force required in this case is 60 newtons. A body of mass 5 kg, so m equal to 5 kgs, is moving with a velocity of 10 meter per second. So your initial velocity is 10 meter per second. A force is applied so that in 25 seconds, so time is 25 seconds, it attains a velocity of 35 meter per second, which is final velocity. 35 meter per second. Calculate the force applied. So here for the mass we saw was 5 kgs. The body had an initial velocity of 10 meter per second. Then a force was applied, and because the force was applied, the velocity of the body changed and the final velocity was 35 meter per second, and this force was applied for 25 seconds. So let's begin first by finding the acceleration, because every time we want force we must know the acceleration. So acceleration equal to v minus u over t. So we go ahead and find acceleration. A equal to v was 35, u was 10, and the time was 25. So acceleration equal to 25 over 25, which is 1. So acceleration equal to 1 meter per second square. Now by Newton's second law, you have F equal to m into a. So F we do not know, that's a question. We know the mass is 5 and we found the acceleration is 1. So F equal to 5 Newton. A 150 gram ball, so here mass is 150 gram, traveling at 30 meter per second, so initial velocity 30 meter per second, strikes the palm of a player's hand, which means it stops. The player holds it, so that means final velocity 0 meter per second, and it stopped in 0.05 seconds, so this will be the time. Find the force exerted by the ball on the hand. So here we see the mass of the ball is 150 gram, and remember gram is not SI unit, kg is SI unit. So we need to change this gram into kg. So we do 150 over 1000 kg. So for mass we have to use 150 over 1000. The initial velocity we've seen here is 30 meter per second. Then the player catches the ball, which means the ball now comes to a rest. So final velocity will be 0 meter per second. And he catches the ball in a time of 0.05 second. We must know what is the force exerted by the ball on the hand of the player. So to know the force, always we have to find first acceleration. So the formula for acceleration is A equal to V minus U over T. And let's go ahead and put the values. We saw the V final velocity was 0 because the ball stopped. The player caught the ball. The initial velocity was 30. The ball was coming with a speed of 30 meter per second and the time was 0.05 second. So now the acceleration will be minus 30 over 0.05. A equal to minus 30. Now I'm going to multiply the numerator by 100 because there are two decimals here and this will become 5. I've removed the decimal by multiplying it by 100. So my acceleration here on working becomes minus 600 meter per second square. Because I'll cancel this out. This will become 6, so minus 600. Now I'm ready to find the force. So F equal to M into A, and remember for the force, I have to write the mass, and the mass has to be in kgs. So it will be 150 over 1000, not just 150. You have to convert it into kgs. And acceleration is minus 600. On working out this, your force comes minus 90 newtons. And why negative? It is a retarding force. An unloaded truck weighing 2000 kgs, so mass equal to 2000 kg, has a maximum acceleration of 0.5 meter per second square. So acceleration 0.5 meter per second square. What is the maximum acceleration when it is carrying a load of 2000 kgs? So we take case 1 when the truck is unloaded. Means it is not carrying any load. The mass of the truck, which is M, is just 2000 kgs. Now the acceleration A is given as 0.5 meter per second square. If we know mass and we know acceleration, we can use the formula F equal to M into A. This will give us the force produced by the engine of that truck. So force equal to mass 2000 into 0.5. So the force produced by the engine of the truck is 1000 newtons. Now in case 2, the case 2 is when the truck now is loaded. It is loaded with 2000 kg. So the mass of this truck is now going to be 2000 is the load, is the mass of the truck plus the load. Load is another 2000. So the total mass is going to be 4000 kgs. This is a loaded truck. Now we need to find the acceleration. Now the force of this engine we have already seen is 1000 Newton. The engine of the truck can produce a force of 1000 Newtons. So we do again F equal to M into A. For force we put 1000, which we found earlier. The mass is now 4000. It's a heavy truck, into acceleration, which we need to find. So acceleration is 1000 over 4000. So acceleration is 1/4 meter per second square. 0.25 meter per second square is the acceleration. How long will it take a force of 10 newtons to stop a mass? Stop means V equal to 0 meter per second, final velocity, of 2.5 kgs, mass 2.5 kgs, moving at 20 meters per second. So this body is moving with initial velocity of 20 meters per second and it has to be stopped. To stop, we are using a force of 10 newtons. So here we see the mass is given as 2.5 kgs. The body is moving with an initial velocity of 20 meters per second. And the body is stopped. Here they use the word stop. That means final velocity 0 meter per second, and the time is, it's what we need to know. The force also is given to us. We call it F, which is 10 newtons. So we start with Newton's second law, which is F equal to m into A. Now here the force we know is 10 newtons, the mass is 2.5, we don't know the acceleration. So the acceleration will be 10 over 2.5, and here the acceleration will be 4 meter per second square. Acceleration will be negative. Why will it be negative? Because remember, this body is stopping, the velocity is decreasing. There's a decrease in velocity, so the acceleration will be taken as negative. Now we know also acceleration is v minus u over t. So here we are now going to do for acceleration, we put minus 4. The final velocity is 0 because the body has stopped. Initial velocity was 20 and the time we needed to find. So minus 4 equal to minus 20 over t. So we have t equal to minus 20 over minus 4. So t is 5 seconds. So force of 10 newtons has to be applied for 5 seconds. Only then will this body, which is moving with 20 meter per second, stop.